Welcome to the introduction to ASCII. In case you've ever wondered what ASCII is, that's what this video is for.
Yes.
So, ASCII is basically plain text. So anytime you see text on a computer, you're looking at ASCII standardized text.
And ASCII stands for the American Standard Code for Information Interchange. Now, ASCII was actually compiled by like a Jedi Knight group of people that got together to decide how this should all be set up and that kind of stuff. It's essentially just an ordering scheme that organizes characters into a numerical arrangement. We were talking before about binary, and you'll notice here that we have values from 0 to 127 and 128 to 255. Since 255 is the maximum value, we can say that ASCII, at least standard ASCII, is an 8-bit character scheme.
Right.
Where characters can only be from 0 to 255. This is a standard ASCII chart that we are referencing from lookuptables.com.
So as you can see on the chart, every character in the alphabet, every uppercase character, every lowercase character, is equal to a number.
And as we go through here, we can see some special characters that are also called non-printable characters, but technically that's not true because new lines are, you actually see a new line in a text document. But these are your special characters, and this is also an alternative way of representing some special characters. So \R is our carriage return. \N is typically a new line feed. We have our tab character, the bell, which is kind of cool.
Yeah.
So if you're writing a program and you want your computer to go beep, that symbol actually makes a beeping sound. Form feed, which is separating pages. Vertical tab, backspace, and null.
And you can see some of the behaviors of these tie back to typewriters or the old form feed printers, where when you're using a typewriter, you have a carriage return that'll slide the typing carriage back to the left. You have your new line feed, which feeds a new line. A new page form feed is that other button you hit on the typewriter that jumps to the next page. So it's very similar to how that functions.
We also could see that we have this arrangement of numerical characters in this sequence from 48 to 57, and our capital letters from 65 to 90. And over here we have our lowercase letters from 97 to 122. So the important thing to kind of realize from this is that in this hierarchy, you can see that numbers have precedence over capital letters, and capital letters have precedence over lowercase letters. So if we were to alphabetize a string, those words containing capital letters in the beginning will be higher in the list than the ones that don't.
And obviously, as you can see, the numeric value on your keyboard, the number 9 on your keyboard, is not actually the value 9 on your computer.
Yeah.
It's really just the character that looks like our number 9. So the computer will always interpret everything as a number.
Yep, absolutely. We want to go on an exercise here. We'll retake Whippet.net, and we kind of run through this ASCII chart, store the values, and convert it to binary. So if you wanted to get a Whippet.net tattoo in binary on your arm, you can use this tutorial to do that.
Sounds like fun.
So first we're going to get the capital W, which is ASCII decimal number 87. Then the lowercase I. Now, as this chart dictates, if you look to the left, the capital I has a completely different value than the lowercase I. So it's very different. So the lowercase I will have 105, and then the capital B, 66, and the lowercase I again, 105, followed by the lowercase t, which is 116. The period character, 46. The N character, 110, and the E, 101, and lastly, T, which is 116.
And now we'll convert that to binary.
So the next thing, like Brian just said, is we'll go through character for character and make an 8-bit binary string for each character. So WIBIT.net equals these numbers, which equals these binary strings, which when we concatenate, that's what your computer sees when you write Whippet.net in a text editor.
So as an exercise, you can try this with your name.
Mm-hmm.
So you can see your name in binary as the computer understands it.
Yes.
So this brings up the concept of a string. So when we use a string in a program, which is a sequence of characters, we can see what the computer understands that string to be, which is a collection of these numerical ASCII values. So now let's take a look at the examples. So the first one is a string as denoted by the beginning and the ending of double quotes, and in that is a sequence of characters. So you have hello, exclamation point character, space character, capital H character, lowercase o character, how are you today, what a lovely day to program. Then we can also see these special characters. So in the second example, we have a line feed. when this string is printed to a console or to a screen, it'll print, this is the first line, and then it'll get to character \hex 0a, which is the new line, or the line feed.
Which is decimal 10, which is where that hex value comes from.
Right. And then it'll start printing on the next line, this is the second line.
Now, one thing to also keep in mind is these hex values are a direct relationship to its numerical and its binary value.
Absolutely.
So when before we were talking about converting a binary value to hex, we showed you that 10 equals A. But we're talking about an 8-bit number, so we have to prefix any single value with the 0 to make it an 8-bit binary value. So that's why this is \x0a instead of \xa.
And then in the next example, we have a hex 0d character followed by a hex 0a character. So the ASCII value of hex 0d is decimal value 13 or character carriage return. So when a screen gets this character to display, it'll take it as a carriage return and then followed by a new line feed. This is the way Windows handles new lines. Windows expects a carriage return followed by a new line to move to the second line. In our last example, there's a form feed character. So this can either be a \f in some programming languages, or it's a \hex0c, the form feed character. So in this example, we would have, this is page 1, form feed character would take us to a new page. This is page 2, form feed character, to this is page 3.
And sort of like Brian alluded to, this is another way of representing these values. So the new line character, which is hex value x0a, can also be expressed as \n. And just like we were talking about with the Windows new lines, you typically see \r/n in Windows new lines, and the form feed is \f. So these are just alternative ways of printing the same characters.
And that's all there is to it.
That's basically it.
There's a lot of websites that have the ASCII chart. It's probably a good thing for you to bookmark. I would try a website like lookuptable.com and use it as a quick reference guide if you ever need to know the numerical values of a character on the keyboard.